In today's video, let us discuss about the operation and working of an MCB. The abbreviation of MCB is Miniature Circuit Breaker, and the definition of MCB is it's an electrical switch that automatically switch off the electrical circuit during an abnormal condition. Abnormal condition here is overload and short circuit conditions. In both these cases, MCB automatically switches off the electrical circuit and saves the load from the source. Now let us see how an MCB looks like both externally and internally. There are many types of MCBs such as single pole, double pole, triple pole and 4-pole MCBs. Here is a double pole MCB and this is triple pole MCB. The input is given in the input terminals which are present here, that is source is connected here and load is connected to these terminals. The source flows from here to the load when this MCB is turned on. And here is the 3-pole MCB, same, you have R, Y, B phases and load is connected here. This is load terminals and these are source terminals. Let us see the single line diagram of 2-pole and 3-pole MCB. Basically, the single line diagram of an MCB looks something like this. If it is a single pole MCB, you have only one pole, and if it's a double pole MCB, you have 2 poles, so on. If it is 3-pole MCB, you have 3 poles, and if it's a 4-pole MCB, you have 4 poles. There are many other single line representations of MCBs, but most commonly and most popular single line representation is this. If it's a single pole, if it's a double pole, and this is for the triple pole. I hope you have understood the single line diagram and you have seen how an MCB looks externally. Now let's see how an MCB looks internally. This is an MCB's cross-sectional area, or this is how an MCB looks internally. This is a bit complex to understand. So before understanding this diagram, I have drawn a 2D diagram or a simple diagram to understand the working of an MCB. So first let's look at that diagram and understand the working. Here is the simple diagram which I have drawn, and this condition is before tripping condition and this condition is after trip. Okay, let's quickly understand the parts which are present in this diagram. This is the contacts. The main important part in this diagram is bimetallic strip, which is this entire strip is a bimetallic strip, and here also this red color is the bimetallic strip. Okay, this is the input terminal, here is the output terminal. Follow my cursor. Okay, here is the latch is connected to the contact. With the help of the latch, this contact will open and close. Here is the trip bar and this is the plunger. Okay, the plunger is used to push this trip bar away so that this latch can move this contact away. In this, the plunger is pushing the trip bar. The trip bar is attached to the latch. The latch is helping the contact to open or close. Initially, the MCB is in normally closed condition, and when the fault is occur, the MCB turns into normally open condition. The load is connected to the output terminal and the source is connected to the input terminal. So the main aim of any circuit breaker is to protect this load from faulty conditions, and this is achieved when we isolate the load from the source, and this is done with the help of an bimetal. So this bimetallic strips help us to open this source from the load side when any fault occurs. Now let us see how this condition is achieved with the help of a bimetallic strip. Let me quickly clear the screen so that you can follow my cursor for the current path. I have cleared the screen. So follow my cursor to understand the flow of the current. Here is the source and here is your load. That is, this is output and this is your input. Now follow the red path. From the source, the current is flowing to the contact. From the contact, the current is flowing in this direction like this here, and the current is flowing through the bimetallic strip and it is connecting to the load. Okay, this condition is before trip condition. Before tripping, the current path is flowing like this. Most of the diagrams which are available in the internet are not connected to this bimetallic strip. Without connecting the diagram to the bimetallic strip, there is no flow of current, because the safety in this MCB is given through the bimetallic strip. So bimetallic strip is very important component in the MCB. So most of the diagrams present in the internet does not have this connection. Without this connection, your MCB is useless. This is the before trip condition. So when is the MCB going to trip means is MCB also have a rating. Let us assume the MCB is having 8 amps current rating. Okay, your load is taking 5 amps in the initial condition. So till the load is taking up to 8 amps current, nothing will happen because your bimetallic strip does not deviate when it's taking below 8 amps or 8 amps current. When suddenly your load starts taking above 8 amps current, let us assume the load is taking 9 amps current. When 9 amps current is passing through this bimetallic strip, you know when current increases, heat also increases because I square R losses also increases. When heat increases in this bimetallic strip, this bimetallic strip starts to bend. Okay, this bimetallic strip slightly starts to bend. That is our after trip condition. Because the heat is increasing, I have denoted this bimetallic strip in red color. As the heat is increasing, in this case, let's assume your load is taking 9 amps current, but your rating is only 8 amps. When the current is increased than the rating of your MCB, this bimetallic strip starts to bend. Now let's understand how this bimetallic strip is stripping the circuit and saving the load. Assume your load is taking 9 amps, but your rating of the MCB is 8 amps only. So when your load is taking 9 amps current, this bimetallic strip starts to bend. When this bimetallic strip bends due to heat, this is your plunger. Your plunger pushes your trip bar. This is your trip bar. So your plunger pushes your trip bar so that your latch can move your contact up. See, before it used to be normally closed contact, and after this bimetallic strip get activated, this is normally open contact so that your current will stop over here and your load is saved from the source side and your circuit breaker saved your load from the source side. That's all for today's video. Stay tuned for the part B, in which I am going to explain you this circuit diagram, which is bit complex. Thank you for watching. This is Sandeep Chakri signing off.